Hi, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at molecular geometry. We start off with an entire page of information. It is an information of different shapes of molecules. This table will always be given to you. I won't give you the information on the regions. However, after this chemquest, you will know how to determine those. So if we look right here over at ammonia, I'm going to skip this example of methane just because ammonium has all three types of regions for us to look at. So first, total electron regions. So total electron regions are the places around the central atom that have electrons. The maximum you can have is 4. You can look and see you have 1, 2, 3, 4 sides that have electrons around it. Likewise, if you look down here you could see like a trigonoplanar or bent shape. If you look, these ones are 3. Around the central atom, you only have 3, 3 places that can accept electrons. With that being said, one of these must be a double bond. That's why you're able to have one less and still fulfill the octet around the central atom. Next, if we go back to our ammonium example, we can look at the number of bonding electron regions. So again, so the previous one, electron regions are every place that can hold an electron. Bonding regions are the places where bonds take place. So yes, ammonium does have 4 places it can have electrons, but only 1, 2, 3 of those have bonds. So remember, bonds are represented by lines. It's a bonding electron region if it has lines or bonds. And then lastly, we have lone pairs. So remember, lone pairs are around the central atom. Remember, a pair is 2. That's why when we look, we have 1 lone pair. However, we have 2 electrons. So remember, electrons are counted as pairs. If you have a pair, that means you have 2 electrons, which is 1. So this information will be used to help you answer the entire chemquest. You will be referring back to this a lot. So the first 3 questions. They're trying to get you to think of definitions or what are the different regions. So use the Lewis structure and then the information given about each region to make your best educated guess. I did kind of tell you what each of the regions were, so you are welcome to re-watch this and get down the definition, not definitions, but get down what each region is. Next, in question four is typically fill in the blanks. So it's giving you some bond angles, and you need to figure out some information on the regions. So you can always look here for the bond angle. All the bond angles are labeled. Once you see the correct bond angle, make sure you pull off the correct information from the table, whether it's asking about the electron region, bonding region, or lone pair region. So then, next with question 5. Question 5, you are going to draw some structures and then try to figure out the shape. So what you're going to do is draw the Lewis structure for A, B, and C. Again, that's using the 5 steps from the first ChemQuest on page 4. So use your 5 steps, draw the structure, then compare your structures to either the structures that are given to you or compare it to how many different regions you have. So you can always figure out which regions you have present. If you have those specific regions, you will always have the same bond angle. So again, you can compare the regions or you can compare the structure once you draw them. Next, question 6. So question 6, you're trying to figure out which one is bent. The hint, it tells you to draw the Lewis structure. So then draw the Lewis structure, and then my pen was starting to die as I was writing this. So after you have the Lewis structures, then compare the regions on your Lewis structure to bent and linear. Try to determine what makes one bent and the other linear. Next, we are coming to some information on Vesper theory. So Vesper theory, this is why every different structure has different shapes. So you have to remember that electrons are all negative. Just like in magnets, when you put 2 negative sides of a magnet together, they repel each other. It's the same thing with an atom. You get these electrons too close to each other and they start pushing back and pushing each other away. So then this will be your definition for Vesper theory. You will have to know that Vesper theory is all of the electron pairs that repel each other, so they want to get as far away from each other as possible. So again, it's your definition. Pause it, write that down on the front. You will need to know this. The key word is repulsion. So repulsion is very, very important to remember. Remember repulsion, repel. Electrons want to repel each other because they have the same charge. Next is question 7. So when you're thinking about question 7, you're thinking about bond angles compared bond angles with bonds and lone pairs of electrons. So what I want you to think about, BA stands for bond angle. So if we're looking at all 4 of the, oops. So if we're looking at methane, ammonium, and water, we're looking at these examples because they all have 4 bond angles. So as you add electrons, the bond angle decreases. Does that mean we are either, so that means we're either pushing the atoms closer together or we're making them further apart? Which one do you think is happening based on the bond angles and the pictures? And then lastly, question 8. Question 8 tells us that you can figure out the bond angle in any kind of molecule, even complex molecules, by identifying the bonding regions and the lone pair regions. So what you need to do is look at the atom that it's pointing at, or the bond that it's pointing, sorry, the atom that it's pointing at, and then figure out the bond angle. You are going to have to identify the bonding regions and the lone pairs. Once you identify how many bonding regions and lone pairs you have, then you compare it to the table up front. So remember, if something has 4 electron regions, 4 bonding regions, and 0 lone pairs, it's always tetrahedral and it always has a 109.5 bond angle. So just remember that, identify the regions, and then you should be able to identify the bond angle. Like always, if you have any questions, make sure you circle them, write down your questions when you bring them to class. You don't have to remember what you wanted to ask me. Hope everyone has a great day.